Let's begin our course here by talking about algorithms and algorithm development, because that's pretty much what we're going to be doing throughout the entire course. We'll be learning tools, Python tools, to solve the algorithms or to complete the work, but really we have to get our mind into the algorithm state of mind, I guess you could say, to really start figuring out how to solve problems. I've written here some pseudocode, so this is the first little thing we'll introduce if you've never heard of it before. Pseudocode is pretty much just writing out code that looks like the actual Python code, only it could never actually run. This one's a little bit better than most, but a pseudocode might say things a bit more in plain English, so you can actually read through the steps and see exactly what you want to be doing, and it doesn't have to consist of actual Python functions or actual Python tools. You could just use plain English to explain what you're doing. So anyways, I've done up this pseudocode here, and we'll just explain the process of algorithm development. So why do we even want algorithms? Like, what's the point of it? Well, algorithms are actually pretty amazing. Number one, they're really, really useful. They're pretty much used everywhere and all the time. It's just you don't really notice it. They're really, really clever. You could have many different algorithms to solve the same problem, and some will be much better than others. It takes a real clever person to come up with a really good algorithm. Next, they make the world faster. Pretty much everything we do now on the internet, or on computers in general, has been made faster on the software side of things because of algorithms. And the thing I sort of like about them is they are problems that solve problems. I love doing puzzles and solving different problems. It's really satisfying to have a solution to a problem that you've been working on for a while. And the great thing about an algorithm is it might take you a little bit of time to figure out how to actually accomplish it. But once you do, it's really satisfying that you've solved that problem. And the benefit of it is that algorithm can be used to solve many other problems down the road. So that's sort of why we want algorithms and why we want to work on them. But what are they really? Well, the low-level explanation would probably be they're just sort of a set list of instructions on how to solve a problem. So, if we have a problem spec that we get, we can work our way through an algorithm, devise a way to solve that problem. So let's dive right into this pseudocode and just see, the process of developing an algorithm. So I have a function here called algorithm development, and we feed it in some problem specs. Problem specs is what we're going to be getting throughout the course here. Maybe there's a puzzle and there's rules to the puzzle, and those would be the problem specs. The next thing we do is we set up a variable and we say correct equals false. So we don't have a correct algorithm yet. And then we enter in a while loop. And the while loop will only stop if we are correct or we are running at a fast enough time for our liking. But if we are neither of those, we're not correct and we're not fast enough, then we begin figuring out our algorithm. So the first thing I've written there is we start off with a variable called algorithm, and then we enter into a function called devise algorithm, passing it the problem specs. So at that stage in the real world, what we'd be doing is figuring out the problem and determining what steps we'd have to make to actually solve the problem. Once we have that done, that's going to be our algorithm. Then we move on to correctness. So our correct variable, we're going to assign that the results of a function called analyze correctness, and we pass that the algorithm. So this will be like running through the algorithm and making sure that it's actually going to solve the problem that we're trying to solve. If it doesn't solve the problem we're trying to solve and it's not correct, then it's not really a good algorithm. Once we have that problem solved, we've met one of the criteria, having a correct algorithm. The next criteria is analyze efficiency. We set up a variable called running time, and we assign a result from a function called analyze efficiency, passing that the algorithm. What this is going to do is measure different things like the cost of the algorithm, meaning the time, the bandwidth, latency, and all that kind of stuff that the algorithm might take up, computing power. If the running time is not satisfactory, we're going to have to go back and start at the beginning and analyze or devise a new algorithm, or change the one we had to solve the running time issue. There's no point in having an algorithm that solves a problem but takes days and days and days. We want these things to be super fast. Once we have a correct algorithm and a really good running time, then we are done and we return the algorithm. That's a pretty basic explanation of how we might go about creating an algorithm. So let's dive in and figure out our first problem set and see how this algorithm for developing algorithms might actually work.